Namaste everyone, hope all of you are well. Today, this is the sixth lecture of S block elements. From 1 to 5, I have discussed about alkali and alkaline earth metals, their properties, physical and chemical, their uses. In group number 1, alkali earth metals, we have discussed about the sodium compounds. In this video especially, we are going to discuss about the important compounds of calcium. In group number 1, we have discussed about the sodium compounds like caustic soda, we have discussed about baking soda, we have discussed about washing soda, and finally we have discussed about the sodium chloride. In this group number 2, alkaline earth metals, calcium elements, compounds, important compounds like calcium carbonate, calcium oxide, and calcium hydroxide. Now question is, important compounds of calcium are calcium oxides, calcium hydroxide, calcium sulfate, calcium carbonate, and cement also. As I have informed you in the previous video that the students which are going to specially make a career in chemist field, for them this is very important. So the large scale and the preparation of these compounds we will discuss. First of all, I am talking about the calcium oxide. You know what is the name of calcium oxide, or the common name of calcium oxide if I talk about? It's also known as quicklime. The chemical formula of calcium oxide, CaO, valency of calcium 2, oxygen 2. So the chemical formula is calcium oxide, CaO, and its general name is quicklime. How it is prepared, how calcium oxide. It is prepared on a commercial scale by heating limestone. Limestone means calcium carbonate in a rotatory kiln at 1070 to 1270 Kelvin. Means when you heat calcium carbonate, CaCO3, when you heat calcium carbonate at 1270 Kelvin, till 1070 to 1270 Kelvin, then you get calcium oxide plus carbon dioxide. The carbon dioxide is removed as soon it is produced to enable the reaction to proceed to completion. Means carbon dioxide is removed as you get a calcium oxide. Calcium oxide is a white amorphous solid. Means you can say it is a solid. In the solid form it exists. It has a melting point of 2870 Kelvin. On exposure to atmosphere, it absorbs moisture and carbon dioxide. Means if calcium oxide, if you do reaction with water, CaO plus H2O, you get calcium hydroxide, CaOH twice, which is also known as slaked lime. Calcium oxide plus carbon dioxide, calcium carbonate, marble. Now question is, the product and the subject. Means from the calcium carbonate you have got calcium oxide, and from calcium oxide, as the calcium oxide do the reaction with carbon dioxide, you will get calcium carbonate, right? So here the addition of limited amount of water breaks the lumps of lime. This process is called slaking of lime. Means here the amount of water breaks the lumps of lime. The process is called slaking of lime. Quicklime slaked with soda and gives solid soda lime. Quicklime slaked with soda and gives solid soda lime. If you ask me what is the nature of this soda lime, it is the basic solution, basic oxide. So definitely, being a basic oxide, it combines with acidic oxides at a very high temperature. Means calcium oxide plus silicon oxide. It will give you calcium silicate, CaSiO3. Now this calcium oxide, if you do the reaction of calcium oxide with phosphorus pentaoxide, P4O10 or P2O5, then you will get calcium phosphate, Ca3PO4 whole twice. Now you have understood what is quicklime, how it is obtained, how it is prepared, and what are the uses now. Question comes of uses. What are the uses of this quicklime? It is an important primary material for manufacturing cement. Dear student, to make a cement, calcium oxide is very important. And this is the cheapest alkali. Means it can be obtained at a very small price, means you cannot say it is obtained at a very high price, it is cheap in rate, so you can say this is the cheapest alkaline earth metal. It is used in the manufacturing of sodium carbonate from caustic soda, as we have discussed in group number 1 also, right? It is employed in the purification of sugar and in the manufacturing of dyestuffs. So this was the story of quicklime. Now we'll discuss about the story of calcium hydroxide, which is also known as slaked lime. Calcium hydroxide or slaked lime is prepared by adding water to quicklime. Means if you add water into the quicklime, you will get calcium hydroxide. As we have discussed in the quicklime only, as we mix the water with quicklime, we got slaked lime, means calcium hydroxide. Calcium hydroxide is also a white amorphous powder. It is sparingly soluble in water. The aqueous solution is known as lime water. Means if you mix this calcium oxide and dissolve into water, that solution will be known as lime water. And it is suspension of slaked lime in water, which is also known as milk of lime. What it is known as? Milk of lime. When the carbon dioxide is passed through this lime water, it turns into milky due to the formation of calcium carbonate. Means this, as we have seen in the calcium oxide also, calcium oxide plus H2O, calcium hydroxide, and this calcium hydroxide is treated with carbon dioxide to get calcium carbonate. So you can say when you do the reaction of calcium hydroxide with carbon dioxide, you get calcium carbonate plus water. On passing the excess of carbon dioxide, you get a precipitation of calcium hydrogen carbonate, means CaHCO3 whole twice, means CaCO3 plus CO2 plus H2O. You will get CaHCO3 whole twice, that is also called calcium hydrogen carbonate. Milk of lime reacts with chlorine to form hypochlorite, a constituent of bleaching powder. You know bleaching powder, CaOCl2. Here you know very well how to write CaOCl2. Whenever you want to write CaOCl2, calcium OCl here and Cl here. In this way you have to write calcium chloride, right? Bleaching powder. Now question is, how this bleaching powder is formed? Milk of lime reacts with chlorine to get hypochlorite. This is a constituent of bleaching powder, means calcium hydroxide plus chlorine will give you calcium chloride plus bleaching powder plus water. So this is the reaction which you should learn, that how bleaching powder is formed. Now question is about where it is used. What are the uses of this slaked lime? It is used in the preparation of mortar and a building material. It is also used as a whitewash due to the disinfection's nature. It is used in the glass making, in tanning industries, for the preparation of bleaching powder and the purification of sugar. So dear student, the question may be asked that what are the uses of slaked lime, how slaked lime is prepared, and how it is done. Now the next question is about calcium carbonate. You know what is calcium carbonate? Can anybody say me? That's a marble, CaCO3, right? So if I asked you that how calcium carbonate is prepared, can you tell me? Anyone? What is the chemical formula of calcium carbonate? CaCO3. Now you can say that calcium carbonate preparation, properties and uses. Calcium carbonates occur in nature in several forms like limestone, chalk, marble, etc. It can be prepared by passing carbon dioxide through slaked lime or by the addition of sodium carbonate to the calcium chloride. Calcium hydroxide plus carbon dioxide gives you calcium carbonate plus water, or calcium chloride plus sodium carbonate gives you calcium carbonate plus sodium chloride. So this is the preparation method of calcium carbonate. So it's very easy, you can write in your notebook that how calcium carbonate is prepared. So calcium hydroxide plus carbon dioxide, calcium carbonate plus water, and calcium chloride plus sodium carbonate gives you calcium carbonate plus sodium chloride. Excess of carbon dioxide should be avoided because it leads to the formation of water soluble into the calcium hydrogen carbonate. Calcium carbonate is a white fluffy powder. It is almost insoluble. Means it is a white fluffy powder. It is almost insoluble in water. When you heat at 1200 Kelvin, it decomposes into carbon dioxide and calcium oxide. Means this marble, as we have done the same process to obtain calcium oxide, right? Similarly here also, if you heat the calcium carbonate, you will get calcium oxide and carbon dioxide. But at what temperature? 1200 Kelvin. It reacts with dilute acid to liberate carbon dioxide. Means calcium carbonate plus HCl will give you calcium chloride plus water plus carbon dioxide. Calcium carbonate plus sulfuric acid. Calcium carbonate, when it reacts with hydrochloric acid, it will give you calcium chloride, water and carbon dioxide. Calcium carbonate reacts with sulfuric acid, calcium sulfate, water and carbon dioxide. The reactions are going to be same. It is used in a building material in the form of marble, in the manufacturing of quicklime, calcium carbonate along with the magnesium carbonate, which is used in the flux in the extractions of metals such as specially precipitated of calcium carbonate. It is an extensively used in the manufacturing of high quality paper. It is also used as an antacid, mild abrasive in toothpaste, as constituent chewing gum, and filler in cosmetics. Means many where this calcium carbonate is used. You know very well, in olden days there was a Colgate powder, you can ask your parents or grandparents, they may be knowing that earlier there was a Colgate white powder tooth. That was not a paste, it was a powdered form, and in that it was being used, this calcium carbonate. Similarly, one more calcium compound is that's called plaster of Paris. You know plaster of Paris, what is the chemical formula of plaster of Paris? Can you see? I hope all of you know. CSO4 into half H2O, right? That's called plaster of Paris. And you can say that calcium sulfate also, right? So it is one more compound of calcium sulfate, right? So can you tell me how this calcium sulfate is obtained? It is also known as hemihydrated. Half H2O is known as hemihydrated. Hemihydrated of calcium sulfate. It is obtained when gypsum means CSO4 into 2H2O. When you heat this gypsum at 393, 273 plus 120, at 120 degrees Celsius, if you heat gypsum, you will get plaster of Paris. Means 2 into CaSO4 into 2H2O is heated at 120 degrees Celsius, you will get calcium sulfate into H2O. So here that's 393 Kelvin, there is no water of crystallization is left, and the anhydrous calcium sulfate is formed. This is known as dead burnt plaster. What is known as dead burnt plaster. Very important to know about it. It has a remarkable property of setting with water. On mixing with an adequate quantity of water, it forms a plastic mass that gets into a hard solid in 5 to 15 minutes. Now if I ask you what are the uses of this plaster of Paris, you can say there is a large use of plaster of Paris in the building industries as well as plasters. It is also used for immobilizing the affect part of the organs also. Means you know that bone fractures we use it. Where there is a bone fracture or sprain, it is also employed in industries or dentistries, in ornamental work, or it is also being used in making casts of statues and busts. So this is the important compound of calcium. Now last but not the least, cement. The student who want to go into the cement industry, who want to work into the chemist field, especially in the cement industry, for them this word is very important. Cement is an important building material. It was first introduced in England in 1824. You know who was that scientist who have introduced cement? His name was Joseph Aspdin. Joseph Aspdin. It is also called Portland cement because it is resembled with the natural limestone quarried in the Islay of Portland in England. So that's why it's known as, what is known as Portland cement. Cement is a product obtained by combining material rich in lime, calcium oxide and other materials such as clay which contains silicate along with the oxides of aluminium, iron and magnesium. The average compositions of this Portland cement is calcium oxide 50 to 60%, silicate SiO2 that is 20 to 25%, aluminium oxide Al2O3 that is 5 to 10%, magnesium oxide 2 to 3%, ferric oxide 1 to 2% and sulfite SO3 that is 1 to 2%. For a good quality of cement, the ratio of silica to aluminium should be between 2.5 and 4. And the ratio of lime, that is calcium oxide, to the total of the oxides of silicon and aluminium and iron should be close as possible to 2. Means as we have seen, the ratio of these oxides of these elements must be approximately it should be equal to 2. The raw materials for manufacturing of cement are limestone and clay. When the clay and limestone are strongly heated together, they fuse and react to form cement clinker. What is called? Cement clinker. This clinker is mixed with 2 to 3% by weight of gypsum. Gypsum means CaSO4 into 2H2O to form cement. These are very important ingredients present in Portland cement, which are dicalcium silicate. Dicalcium silicate for chemical formula Ca2SiO4. Remember the formula of dicalcium silicate. Got it? Now if I talk about tricalcium, 26% of tricalcium silicate. Tricalcium silicate formula Ca3SiO5. That's calcium trisilicate. That must be 51%. Calcium aluminate, if I talk about it, must be 11%. That is Ca3Al2O6. Now how the cement is being settled, you know, when there is a mixing with water, there is a setting of cement. You know, sometimes when we especially bring a cement for our building purpose or construction purpose, and when rain comes, you will see there is a setting of cement. When this cements are mixed with water, then there is called a setting of cement, which take place to give a hard mass. This is due to the hydration of the molecules of constituents and their rearrangements. The purpose of adding gypsum is only to slow down the process of the setting of cements so that it gets sufficiently hardened. And you know where are the uses of this cement. Cement has become a commodity of national necessity for our country. It is next to iron and steel. It is used in concrete and reinforced concrete, in plastering, and even it is also being used in the constructions of bridge, dams, buildings and everywhere, you know, right? So you can't say that without cement you can make a high building or high dams. It's very difficult, right? So there are so much importance of the cement. Now there is a last topic of this whole chapter, as we have discussed that what are the uses of sodium and potassium in group number 1, right? So if I talk about in this alkaline earth metal, then we have to just say that what are the importance of the calcium and magnesium in our body. It means biological importance of calcium and magnesium, right? So can anybody say me that how much gram of calcium must be present in a normal human being, which can weigh 70 kilogram? Normal human being, just see how much grams should calcium must be present in a body? Can you see? In an adult, there must be 25 gram of calcium. How much gram? 25 gram. In an adult human body, there must be 25 gram of magnesium, and 1200 gram of calcium. Yeah, 1200 gram of calcium means 1.2 kg. This calcium means whole bone. Are you understanding? Whole bone is made up of, when your bones get weak, doctor prescribes you about for calcium tablets. You must take calcium. You should eat drumsticks. In the drumstick there is a lot of calcium. So whenever we get a bone fracture, doctor prescribes us calcium tablet. In the whole body, if you count the calcium percentage, there is 1.2 kilogram of calcium in a normal human body, and 25 gram of magnesium, not 25 gram of calcium. Sorry, that is. Now calcium, if you compare with iron, 5 gram of iron and 0.06 gram of copper. The daily requirement of the human body is estimated in 200 to 300 milligrams. Means every day, whatever the amount of minerals, whatever the amount of these elements are being used in our body, that must be approximately 200 to 300 milligrams. It is all the enzymes present in our body that utilize ATP in phosphate transfer, require magnesium as cofactor. The main pigment for the absorption of light in plants is chlorophyll, very well, which contains magnesium. In the plants, in the chlorophyll there is Mg2+. About 99% of the body of calcium is present in the bones and teeth. Our whole body, if I talk about in 1.2 kilogram, 99% is present in bones and teeth. It is also plays an important role in neuromuscular functions, interneuronal transmission, cell membranes, integrity, blood coagulation. The calcium concentration in plasma is regulated at about 100 milligram per liter. It is maintained by two hormones. You know that name of hormones? That is called calcitonin and parathyroid hormone. Do you know the substance? But it is continuously being solubilized and redeposited into the extent of 400 milligram per day in a man. All the calcium passes through the plasma. So there is a great importance of calcium in our body. Calcium and magnesium must be present in our body. 25 gram of magnesium, if that will be not present, then you can understand. If I ask you, what is the uses of calcium? If you don't take calcium, what will happen? You will not be able to properly stand also. Why? Because as you have seen, 99% of calcium is present in your bones and teeth. If you will not have this thing, then you can remember that what will happen to your body. So dear friends, very important to have all the nutritions in our body. From lecture number 1 to lecture number 6, you must remember the things which I have taught you from lecture number 1 to this lecture, because the things which are important, leave this education, leave the marks, but actually you should think about the uses of these things in our daily life. See, learning and studying, these are two different things. Learning means it is the applications of knowledge, and studying means to gain maximum and more marks. So dear student, whenever I speak learning and studying, learning means you are having the applications of knowledge in your life. Whatever the study, sometimes by many of the students watch movies. While watching movies, what do they get, While watching movies, they understand these things and they do the applications of those things in their life or in anybody else's life. They can see. What do our motivators do, Have you ever thought about the motivators like Sandeep Maheshwari or big motivators are there? What do? They study the articles of motivation and they do practical in the other's life. That is called a motivational speaker, nothing else. They make you those things feeling in your body. That is called motivational speaker. Similarly, whatever the things we are learning, we are studying, it must be applicable to our life. in this whole S block elements, alkali and alkaline earth metals. Alkali group number 1 and alkaline group number 2, right? Lithium to cesium, beryllium to barium, leave francium and radium. They are radioactive elements. The things which we have studied, that's not a general thing. All the alkali and alkaline earth metals are unique. Each and every element has some uses, as we have seen the anomalous property of lithium and beryllium in group number 1 and 2 respectively. So the things which you are learning must be accommodated in your mind, that anytime if anyone asks you, if a question comes in front of you, you should read the question, you should understand the question, and then the things which is accommodated in your mind, it must be used while understanding those questions. I hope all of you have understand this lecture number 6. If you have any doubt related to this whole S block chapters, then you can drop your doubt into the comment box section. Second thing, please make a note of this whole chapter. In this whole chapter, I hope that things which you have remembered, like, first of all, you will write the group number 1 elements name. Like, what are the group number 1 elements name? Hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. 7 elements are there. Hydrogen we have read in the chapter number 9. Whole hydrogen is completed, right? So from lithium to francium, but we have to link the francium also. Lithium, sodium, potassium, rubidium, cesium. 5 elements you have to learn in group number 1. Lithium has an anomalous property. So except lithium, the rest are the main alkali earth metals, monovalent electropositive elements. Write the electronic configurations of the elements, ionization enthalpy, hydration enthalpy, all the physical properties like density, melting point, boiling point. Remember those points, each and everything in your mind. Similarly, you have to do of group number 2 also, alkaline earth metals also. Alkaline earth metals means beryllium to radium, but we have to leave the radium. Beryllium, magnesium, calcium. After calcium, can you tell me? Strontium, barium, radium, right? So you have to read these all the elements, what are the importance of these elements in your daily life, in the biological portion, in the companies, especially about the cement, especially about the baking soda, caustic soda, salt, washing soda, the uses of this group number 1 and group number 2 elements, right? Those things, all the chemical properties, reaction with oxygen, reaction with water, reaction with halogens, reaction with other things, hydrides, hydrated forms. After chemical properties and physical properties, you can write the uses of these each and every elements in other fields also, that where they are being used. After writing all those positions, step by step if you will write, then it will be able to learn, right? It will not be very much difficult that it will be not able to understand, it will be not able to write, it will be not able to learn. So nothing is going to be happen. Whatever the things I have said you, write according to that. Whatever the things you have learned in lecture number 1, lecture number 2, lecture number 3, lecture number 4, lecture number 5 and lecture number 6. Consume all those things. If you want to make a flow chart diagram, just suppose that you are going to make a flow chart diagram of this whole chapter. Group number 1, group number 2. Similarities between group number 1 and group number 2. Differences between the group number 1 and group number 2. Anomalous property of group number 1 and group number 2. Lithium and beryllium. Now diagonal relationship of lithium to magnesium and beryllium to aluminum. So the things which whatever you have learned, make a flowchart diagram. Now just suppose that you are going to teach this chapter. So now as the question comes in front of you, that time you will be able to understand, yeah, really sir, I have said these things, we must do these applications in each and every chapter, so it will be comfortable for us that really these things are very, very important. So I hope that all of you will do these things in a notebook. If any time you feel that sir, I have not understood this topic, then please message me or call me, or you can comment also through this video's link. So as you will comment, then I understand that my student has not understood this topic. I have to make him more and more understand. Hope all of you have understand this chapter. If you have any doubt, please drop your doubt into the comment box section. Right? The present students are also, if you will have doubt, then just watch this video. I am going to upload this video. So you have to watch this video. If you have doubt, then you can also comment those videos. Comment your doubt into the comment box section. That's all for today. Thank you very much. Don't forget to like and subscribe.